Good evening, everybody. Welcome back to TACO After Dark. John Barba here, along with Dave Holdorf and Rick Mayo, our two ACE regional trainers with TACO. And joining us from the great state of Minnesota is Patrick S. from Mondale Associates. Our guest speaker tonight is going to talk to you about the fine art and subtle science and the overall importance of boiler water treatment. So this promises to be a really cool session of TACO After Dark. So welcome, Patrick. We're really happy to have you with us. And for you folks out who are joining us on this Tuesday night edition, we did the same program last Wednesday, and we're repeating it again later on a Tuesday evening for folks maybe out in the western half of the country who just can't quite make our earlier presentation. So this is kind of an encore for Patrick, and we've seen Patrick do this program several times, and you guys are in for a real treat. It's one of the very best I've ever heard on this particular topic. So we're real excited about that, and to the point where even Bruce Campbell, our patron saint of TACO After Dark, approves. He's got his margarita ready, and he's just anxious for Patrick to get started. So don't disappoint Bruce Campbell, Patrick. That's rule number one of TACO After Dark. Don't disappoint Bruce Campbell.
I don't have the margarita, but I'll get close.
There you go. For those of you first timers out there, what is TACO After Dark? Well, for this session, it's a 5-week online program. We've been doing, this is our second presentation. We have 3 more for the winter season, and then we'll get into the spring season, which will be a multi-part series showcasing our factory training program. We'll be doing that starting, I'm going to guess, in April. And that'll be going on for 10 weeks. But this is our 5-week kind of interim shoulder program for the middle of winter. Individual class registrations, which if you've been to the first couple, you already know, it just works out better that way. It allows for more back and forth communication between us and you, and it allows for you to have access to the recordings in 24 hours. So about this time tomorrow evening, you'll get an email from us with a link to the recording, as well as a link to download your certificate of participation if you so want one. So that'll be available to you starting tomorrow night for this session. But that individual class registration allows us to do that for you. Prizes for participation. If you were with us last week, you know we love giving away T-shirts. We got some really smoking TACO After Dark T-shirts that we love to give away. We're going to have a trivia question in the middle, and then we'll find other reasons to give T-shirts away just because we feel like it. So the more you participate, the more questions you ask, the more comments you make in the question and answer section, question and chat section, the better your chances are of walking away with a nice little T-shirt. And as always, we hope to have a lot of learning. We certainly will tonight. I know that for a fact. And we're going to have some laughs along the way as well. And one of the ways in which we kind of have some laughs is we have a little theme for every night. All right, we're going to get to that theme in just a second. I just want to go over the control panel basics again for you first timers. Way up, if you look on your control panel, if you see an orange arrow pointing to the left, click on it. That will expand the control panel. And once it's expanded, you can see all this cool stuff. First off, microphone and speakers. Your microphones are muted, but you want to make sure you got your speakers on. Another area is for downloads. We don't have any downloads for you this evening, but we will in future events. So that's where you'll find them. And then lastly, and most importantly, the question and chat section. That's going to be where you ask questions or make comments or tell us what you're thinking. So Daryl Fern already has figured that out. He typed in a hey howdy. We got greetings from Alberta. Let's just check in. Where are you guys from? Where's everybody from out there? Just type in a hello and where you're from. We've got Ken, who's from Alberta. Great, Ken, welcome. Portsmouth, New Hampshire. There's Robert, again, just down the street. Robert, how you doing, man? Eric is with us. We got Wichita, Kansas. We have Alaska. Tracy, welcome. Daryl's from Eastern PA. Right here, Rob's right down the street. We got Colorado. We got Phoenix. This is excellent. Good, awesome. We're glad to have you with us. Fergus, Ontario. Excellent, Mary. Welcome. Glad to have you back, Mary. I remember you from previous episodes. So great, excellent. So good. Everybody knows how to do that. That's important. Again, when we do trivia, when we do other stuff, that your participation is important, and this is how you're going to participate. If you are on a phone or a tablet, okay, this is kind of the layout here. The question function is right down here. That little question mark down in the corner. Just click on that, and that'll allow you to ask questions, so you can type them on it. Cool. Now, just a reminder, just to, for a lot of folks, we've got a lot of cool stuff going out on social media, particularly announcements about training programs, upcoming classes, registrations for TACO After Dark, TACO Tuesdays, etc. So follow us on social media. Monday Night Live, Dave Holdorf and I will do Monday Night Live on Instagram Live, where we get together and we'll talk and answer your questions for as long as you guys want to stay. We have guest speakers as well on Instagram Live, and here we show where we did a presentation from the floor of the AHR trade show in Las Vegas a few weeks ago with Eric Awney and Andy Mickelson from mechanicalhub.com. They were with us, but we have other speakers as well, other guest speakers as well, or guest question answerers as well. And in the fall, we're going to do a big Monday Night Football pregame show again. I think that went pretty well. So it went well for me last year. I won the bet. So, and Dave had to pay for golf, so it worked out all well. Also join us on Instagram. TACO Comfort, TACO Training is Dave's page. J Barba TACO Trainer is mine. So if you want to follow us on Instagram, that would be awesome. If you follow TACO Comfort, when we go on live, you'll get a notification. So that'll be the best way to follow that. And also check out our Facebook and YouTube pages. We've got a boatload of videos on YouTube, all kinds of past presentations on TACO After Dark, etc. Those are all on YouTube. TACO Tuesday recordings are on YouTube. Product videos are on YouTube. A lot of how-to things. Be a great resource for you. And then also follow us on Facebook, where we post regularly, pretty active there with the same thing: video, news, different links and things that might help you out. So that would be to your advantage, but of course. Now our theme tonight, because we always have a theme, and because we all grew up. I'm a boomer, all right. Rick's a boomer. I don't think Dave and Patrick are quite boomers yet. I'm not sure. So most of the stuff is 60s and 70s TV shows, because that's what we grew up on. And our theme tonight is one of the great cop shows of all time, Barney Miller. Now, if you remember Barney Miller. And we have different characters. So Dave, you consider Dave to be Barney Miller. That's why he's wearing the tie. Okay, Dave's good. He's wearing the tie. Rick is Wojo. We made Patrick Lieutenant Dietrich just because he's the most intellectual of the bunch. And you're probably wondering where I am. Well, I'm over here for a very good reason. All right, I'm Fish. And it's not because I'm the oldest. Rick's got me by a couple of years. There's a very good reason I gave myself Fish, and we just saw it one slide ago. That's look at that. I go, when the hell did that happen? Not too long ago, I was a very attractive man. I don't know what happened. When did I lose my hair and turn into Abe Vigoda? I don't understand. I just know that it hurts. It hurts so bad. But anyway, take your shots now, folks. Just take them now. It's all fair game. So with that said, my man Abe and I, we're going to say, let's get started. Let's get this show started. And what I'm going to do right now is I'm going to turn the baton over to Patrick. So Patrick, I'm going to make you the presenter, and you can take it from here, man.
Take it away. Okay.
There we go. And as always, folks, ask your questions as they come up. We will be, we'll every few slides we'll take a quick break for the cause and answer some questions for you, and then we'll continue. We don't like to wait till the end and say hold your questions till the end. That's kind of silly. Ask them as they occur to you, okay? And then we'll try to answer them as we take our periodic breaks, and we will stay on as late as you guys want to answer your questions once we're done. And at that point, it's a free for all. Any question you have is fair game. So take it away, Patrick. Let her rip.
Perfect, John. Thank you. And we will dive right into this thing. So tonight we're going to talk about a topic that's very near and dear to my heart. We're going to talk about boiler water treatment and some of the, I guess, solutions to the problem. Not just the problem, but actually some solutions to it. Some of the benefits of water treatment, obviously, to improve, maintain system efficiency, to prevent system breakdowns, reduce fuel costs, minimize environmental impacts, reduce callbacks. And the last one is a big one: comply with manufacturers' recommendations and requirements. Now, I've always said there's all kinds of people in the industry. It's not to judge one or the other. It's just, it's different strokes for different folks. You know, when we're looking at water treatment, some people may look at it and say, well, you know, the system efficiency, I'm really not worried about that. I just put the boilers in. I don't pay the bill. It's not my problem. I just put them in. Prevent system breakdown. I don't do service work, so it really doesn't matter to me. I just put the boiler in. Reduce fuel cost. You know, I'm not too worried about that. It's not my problem. I sell the boiler. I move on. It's then the homeowner's problem, so it's really not an issue for me. Minimize environmental impact. Yeah, you know, I'm not so sure I buy it. I think it's a pink unicorn. I think it's all made up, right? There's people that feel this way. Reduce callbacks. I don't do callbacks. I turn my phone off at 4 o'clock. I go to happy hour. I don't worry about it. I go to work the next day. It's not a big deal. So there's a lot of people that may fit what I just described, and that's fine. Some of you, you know, I think may probably make better decisions than I do when you consider the lack of stress on some of these issues. But the one at the bottom, no matter who you are, it affects all of you. Complying with manufacturers' recommendations and requirements. No matter what type of contractor you are, no matter what type of business you do, that's one, if you're putting boilers in, it should matter to you, and it's going to matter to you. Simply because there's a term in the industry now that most, if not all, boiler manufacturers are using. It's called credit upon evaluation, okay? Most boiler manufacturers are now saying, you know, if that heat exchanger, if it fails and it's under warranty, we want to evaluate that thing and make a decision based upon the condition of that heat exchanger. And we want to make sure that it actually falls under a warrantable condition. We want to make sure that this water wasn't running through that system, okay? Because this isn't a warrantable condition. Every boiler manufacturer that I'm aware of typically has a pH range and acceptance range of 6.5 to 8.5 pH. pH is kind of a funny scale. At 7, pH is neutral. If I get lower than 7, I become acidic. If I'm higher than 7, I'm running alkalinity, both of which will cause corrosion, and they will take boiler water, clean and clear boiler water, and it will cause corrosion from the parts and pieces in your system, and it will create black water. Yes, this in fact is not what boiler water is supposed to look like. We'll talk about that in a bit. But no matter what type of contract you are, boiler water actually does matter, and it should matter, and it's going to matter. Because if there is a warrantable condition on that system or something that falls in the time frame of warranty, boiler manufacturers are going to want to inspect those systems with that credit upon evaluation situation we just talked about. So what are the problems? Well, the problems are corrosion, line scale. Some of the problems with corrosion, all mixed metals in systems corrode. So even if you have perfect water, technically, if you have different mixed metals in a system, they will corrode, okay? Ferrous metals corrode to form sludge, okay? General and localized corrosion can happen. In some situations, localized pitting corrosion can actually become very rapid depending on the pH of the water. Is there oxygen in the water? Are they getting rid of all the air? Okay, those are all things that can cause corrosion. Black magnetite and red iron rust are typical from those environments. Or as Takeo refers to it as black iron oxide or bio, okay? Remember, when we have corrosion in a system, all of these parts and pieces from that system are going to float around into that system. And if you're familiar with ECM pumps or ECM technology is using a electrically commutated motor, okay? The one thing all ECM pumps or motors have in common is the rotor on the motor it's a permanent magnet, okay? And the problem with the permanent magnet is this, okay? All of that black iron oxide in the system is going to collect to the magnet, okay? Fortunately, if you're using Takeo, your pumps have what is called a bio barrier that prevents that black iron oxide from ever getting into the rotor on the pump. It's protecting the pump. But again, these are all reasons we want to be concerned with water quality, because we really don't want this floating around in the system. All these parts and pieces are a product from corrosion. And what happens with those parts and pieces is they end up collecting to the hottest point in the boiler. Well, where might the hottest point in the boiler be? The heat exchanger, okay? So all that corrosion, all those particles in the system are going to act like a magnet to the hottest point in the boiler, which is actually the heat exchanger. And they're going to start to plug that heat exchanger up. This is a favorite picture of mine. This is actually a fire tube heat exchanger. You know, the fire tube that everybody said, well, these are the great heat exchangers. They don't require maintenance, and you know, they can really handle poor water quality because they have mass and they allow flow. The problem with a fire tube heat exchanger is simply this, just like every other heat exchanger. All of the contaminants, all of the particles from poor water quality collect at the hottest point in that heat exchanger, which is up at the very top where the burner sits in a chamber, and then those flames shoot down inside of these tubes, okay? And as you can see, that hot burner chamber now is it's no longer surrounded by water, it's actually insulated. And the problem with it is simply this: the heat cannot get into the water. If the heat can't get into the water, where does it go? It's going to go out of the flue. It's going to overheat your burner chamber. It's going to cause short cycling. If we short cycle a boiler, what are some of I guess the issues of a short cycling boiler? Igniters, venturis, vent motors, cracked heat exchangers, cracked welds on the hot point, failing gaskets up at the top of that unit. Okay, if these things sound familiar to you, you may want to start looking at what's the water quality on that boiler. It isn't, in fact, short cycling and overheating. Okay, water quality is a big culprit to premature failures on boilers and heat exchangers. It's one of the reasons that most manufacturers out there now are saying credit upon evaluation. I want to see this thing, because if it shows up at the factory, we cut it open and we see this, by no means are we obligated to warranty this system. Okay. Here's a Giannone heat exchanger, and you can see, look at how that black iron oxide, that black iron red rust magnetite started to build up at the hottest point and started going through. And most people look at a Giannone and they say, well, the problem is, look at it's restricting flow, and it's preventing flow from going through the heat exchanger, and that's the problem with it. And that's why with the Giannone, you know, we try and do fire because it restricts flow. The problem isn't the flow. The problem is I can't get the heat into the water. Okay. Again, if the heat can't get in the water, where does it go? It's going to go out the stack. All right. What are most ModCon boilers vented in? Most ModCon boilers are vented in PVC. PVC has a heat limit of 150 degrees or less. If you're seeing brown, black, cracked, sagging, melted PVC on the vent, I can pretty much reassure you either one of two things. Number one, you probably have a plugged up heat exchanger and you're running high temps because you can't absorb the heat. Or number two, you're running a high temperature application with the wrong venting material. Either one is a recipe for disaster, okay? So these are some of the reasons why water quality is so important and why we need to address it, look at it, recognize it, and understand it. There's a lot of systems out there that you may have not installed, and you're looking at it going, okay, well, fine, how do I know my heat exchanger is plugged like this? And I'll tell you a couple of the indicators here in a second. Okay, this is showing another Giannone heat exchanger where you're showing the burner sits inside of that, and that burner emits heat 360 degrees. That heat then has to penetrate through that black collection there and get into the water. And you can see it creates a big problem for that heat to get into the water. Not only am I restricting flow, more importantly, I'm restricting the heat from getting into the water, which is the bigger problem. Okay, here you can see a Giannone heat exchanger that was actually turned in for warranty. Fact of the matter is, because of the lack of maintenance on the system, I can assure you this boiler was not looked at annually like they're supposed to be. And the lack of water quality, the heat ended up burning right through the back of the secondary, the refractory that separates the primary from the secondary heat exchanger, that white refractory, and ended up burning right through the back of the boiler. Okay, so when we're looking at boiler water quality, how do we address the situation? How do we prevent this from happening? How do we keep our boiler water looking like this? Okay, and it's pretty simple. We want to use inhibitors or protectors. Okay, when we're using protectors, some of the things I look for is, number one, I want the protector to prevent against corrosion and scale. I'd like it to last quite a while so that it's not breaking down and not becoming corrosive on the system. I want it to maintain the design efficiency of the boiler. I'd like it to prevent pumps and actuators and air elimination devices and things like that from failing and plugging up. Protectors will also help reduce boiler noise, okay? And they're also going to help reduce maintenance costs, all right? When you're looking at protectors, you want to make sure that the protectors you pick treat all mixed metals in a system, including aluminum. That's a big one, okay? The other thing is you want to make sure your protectors are non-toxic, non-foaming in systems, okay? And you want to ensure that the protector you're using, and this is a big one, you want to ensure that the protector you're using falls in line with the required pH of the boiler system. I can't tell you how many times I've ran into, typically on bigger and larger commercial projects and commercial jobs, where there is a hired boiler water treatment or a water treatment company that comes in and they're required to maintain the boiler system. Generally speaking, they're always concerned about what the requirement of their chemical is, not the requirement of the boiler. There's been plenty of times where, in fact, the chemical they were using was out of that 6.5 to 8.5 pH range that the boiler manufacturer was looking for. Okay, remember, they're chemical experts, not boiler experts, and you need to be aware of that and be recognizant of that, because it's your system and you're responsible for it, and you need to know what works and what doesn't work. So if you're working with a chemical company, ask them, what is the pH of the product they're using? Does it in fact work with the metal system that you're introducing it in? And how long do those inhibitors last? Those are good things to know when you're talking about boiler water treatment. The other thing is, before we'd ever use a protector, we always want to flush and clean a system out. It's just good practice and it's important, okay? So you want to identify the problem, all right? Part of identifying the problem is looking and recognizing water like this, okay? When I was a young man getting in the industry, I did a lot of work with some very talented people. Some of those people were trained by a guy that was trained by a guy that was trained by a guy that was trained by a guy. So then I was trained by that guy. And I will tell you this in all honesty, when I was trained, I was taught that this is what boiler water looks like. This is just, see, that's just dead water. That's what happens when the oxygen's removed from the water, it turns black like that. Oh, that stuff there, oh, that's some really stinky water. This stuff here, that really remove, this stuff can transfer heat really, really well. This is a really good heat mover, okay? All of those things I was taught, okay, back in the very early 90s, all of those things are false, okay? Where we recognize that was false when we got into modulating boilers. We need our water to stay pure and clean like this. We don't want corrosion. I just showed you pictures of why we don't want corrosion, because the particles and pieces from the system, the products of corrosion, are actually going to collect and plug your heat exchanger up and cause a lot of problems, okay? So number one, you want to identify the problem, okay? And then you want to address the problem simply, okay?
Hey, Patrick.
Yes.
I was going to interrupt you real quick. Just want to do a quick status check with everybody out there. How's the pace? How are we doing? Good information. If you're out there, just give us a little check-in the chat section. Make sure that you're still alive out there. And any questions you have for Patrick, chime in when you're ready. So just let us know how the pace is going and everything, and we shall see what we shall see. All right, terrific.
I was always told when you went to a job site early in the morning and you had some of that dark water out of it, man, it was better than coffee.
Oh yeah.
Yeah, it'll wake you up.
Yeah. Oh, just take a couple swigs of that, man. You're good to go. Yes. It's just like coffee, man.
Indeed.
There's an interesting question from Robert. Are artificial or are sacrificial anodes a possibility in the hydronic field? Not really, because they're designed to, well, the anode rods that you see in a water heater are designed for a specific purpose to help save the life of the water heater. But Patrick, your thoughts?
Well, I understand the question, and it's a very good thought. The problem is this is a closed loop system. So anything that's getting sacrificed is going to end up floating around in that system. It's not like a potable system, you know, like a standard potable water heater, right? The anode takes the hit, the particles and stuff run down the drain, whatever, sometimes you drink it, whatnot. But remember, on a closed loop system, anything that's being sacrificed is going to end up staying in the system. It's not being removed, right? Unless we have some type of filtration device, such as magnetic filtration, that we're servicing to remove that. But no, I would say you don't want any type of a sacrificial piece in that system. You're far better off putting in what I've got on the screen here now, a protector. We have with Fernox, one of the products that we actually represent at Mondale and Associates, a company that I've worked for almost 9 years now. One of the products we represent is Fernox, and there's other manufacturers out there of inhibitors, okay? like I said earlier in the slide presentation, make sure you know what they are, make sure you know their limitations, make sure that it's going to work in the heat exchanger or the metal boiler that you're using. And then last but not least, know what the pH of it is. Make sure it's even acceptable to be in the system. One of the benefits of the product that we rep, product on the screen here with the F1 is it has a pH of 7. And almost unbelievably, if the pH is high or low, when I inject this into the system, it automatically neutralizes that pH to a 7, 7.5. Okay, and you can see these two containers here. I don't know, John, can you see the date on this? Can you read that?
12/16/11.
These
So
are from
December
2011.
16th, 2011.
These are from 2011. Okay. These were there before I ever started. I started at Mondale in 2013. I knew about Burnox by then, okay, but I didn't actually start repping the product till 2013. You can see same water, same fittings. This was treated, this was not. Now this turned a bit yellow simply because of UV. If it's exposed to the sun sitting on a desk or whatnot, it'll actually turn a little bit yellow. It's fine, it's not a big deal. But the fact of the matter is this inhibitor lasts a long time. Okay, very impressive product. When you consider the fact that all I have to do is inject one of these cans into that system and know that this particular can, the newer cans, they used to be blue, now these are a little bit bigger. This can treat up to 34 gallons. Okay, I can't overdose it. I can't put the wrong product in. I can't put it in. It's going to work with every metal, every product out there. And the inhibitor of this product is going to outlast the life of that boiler. By putting that into that system, I can ensure that I'm not going to have any type of breakdown. So I'm not going to need a sacrificial piece in that system because it's not going to be a corrosive environment for the metal or for the system. Okay, these inhibitors are fantastic for systems. Yes, there's other inhibitors out there. Just know what you're using with those other inhibitors. The benefit of this product, in my opinion, it's the easiest one to work with. You can't screw it up. Can't overdose it, can't put too much in. You can, in fact, underdose it. We'll talk about how to check that a little bit later on. But the reality is it's very simple to work, very effective, and it should outlast the life of the boiler. Okay.
We've got a couple questions that just came in here too. One was a good one. Will these additives and cleaners pose any problems with PEX tubing or various gaskets?
None at all. None at all. They work very well with PEX, aluminum, cast iron, stainless steel, copper, you name it, it works in it. There's not a product that I am aware of that this is not acceptable in. I haven't found anything in 9 years.
Okay, very good. A couple of other questions on deck, but continue, and then when we come out of the trivia question, in a few minutes, we'll get to the next set of questions. So go ahead.
Wonderful. Okay, so this is my youngest son, Jacob. Jacob was about 6 in this when I took this picture. He was helping me do a little bit of work on my system at home. I will tell you the system that I had at my house, I put a glycol in, I don't want to name names just because I don't want to pick on anybody, but it was very common used glycol in the industry. I didn't know about Burnox. I certainly didn't know about the Burnox glycol when I did my house. And when I started at Mondale, I learned quite a bit. At almost to the date, at year 5, my expansion tank got a pinhole leak in it, and it's in-floor in my basement and in-floor in my garage. So this is an in-floor system, okay? My expansion tank got a pinhole leak in it, and my pH level was up around right about 10. If I remember correctly, this would have been back in about 2014, I think would have been 2015 would have been the date. So I put a VT2218 pump on my system because I wanted to put that pump on there. Awesome pump, by the way. I changed the expansion tank out. I threw a Zillman expansion tank on there. I took a picture because a lot of guys asked, how do you install this can? Like, what do you do? So I wanted to get a picture of it. So, of course, Jacob wanted to help me out. He was pretty upset that I took his picture, but I told him, hey, if you don't let me take my picture, if you don't let me take your picture, you're not gonna be able to help me. So there he was reluctantly letting me take his picture. But it shows very simply, you hook the can up to a boiler drain, you loosely connect it to the can, open the boiler drain up, let a little water pee out, tighten it down to the can, and then pull the trigger back. Okay. Pull the trigger back very hard. Sometimes it feels like you're going to break the trigger. You're not going to break the trigger. Pull the trigger back. It will inject into the system in about 45 seconds. It does not have an aerosol. It does not have a propellant. What it is a baggie of fluid inside of this can. So I've got pressure on the metal wall, and when I depress the trigger, the pressure squeezes the baggie of fluid into the system. So you're not putting any aerosols or propellants into the system. It is the simplest way to inject this into a system. Now you'll notice on the picture there's actually a white connection. Back in the day, they didn't come with a hose connection on them. So the Mondales, the owners of the company, actually would bring boxes of these home, and on their weekends they'd spend putting these caps on the containers. Well, fortunately, Furnock started sending them with new caps on them. The one thing I will tell you about these caps, in some situations, you need to use a channel locks and really tighten this cap down to the boiler drain to get it to seat. The threads don't always match up, but I will tell you, if you really crank this down with a channel locks, it'll seal up and it'll work out fine. I've done it several times. And if you ever get your hands on any of those white caps, keep them, save them, use them. You can use them again and again and again. Okay?
Hey, Patrick.
Yes.
Clarify for people, I think I got what you meant by it, but Inflor actually being a brand, and initially when it came out, it was polybutylene. Is that what you're referring to when you said you had an Inflor system, or were you just referring, generally speaking?
Yeah. Good question and good clarification. So when I refer to Inflor, I'm referring to PEX tubing. Okay, there's many PEX manufacturers in the industry. We actually, for Minnesota, North and South Dakota, we rep Rayhow. It's an angle method PEX A tubing, and there's different characteristics of the PEX, but really most PEXs are cross length. So it makes them stronger and whatnot. But the reality is this: when we refer to Inflor, we are referring to PEX tubing in the floor, okay? And they're using the floor as the heating mass. So you're putting warm water into the floor, and then that floor becomes your radiant device to actually, it's your emitter. It's emitting heat. Does that answer and clarify it well enough?
Well, just clarify whether it had a oxygen diffusion barrier or not.
Yeah. Okay. So if you're using, my opinion.
No. The product that you were using, did it have an oxygen barrier or not?
Yes.
That's installed in your house.
Yes. My house had oxygen barrier tubing. If you're not using oxygen barrier tubing, okay, you need to make sure that you're not using you're using ferrous. I'm saying that correct, right? No, non-ferrous metals, right?
Right. Yeah. You want all non-ferrous materials because
non-ferrous. So that means
the oxygen will kill it.
Stainless or bronze. You need to make sure that you're not using anything that's going to break down or rust or break down from oxygen in the water. Because remember, when we heat water, water is like a sponge to oxygen. And believe it or not, oxygen can pass through plastic. That oxygen barrier on the tubing prevents the oxygen from getting into the heated up water. If you use non-O2 barrier tubing, the downfall of that is simply this: oxygen's going to get into that water, so you better make sure that you're using non-ferrous metals such as brass or bronze or stainless steel. That's not going to sit and break down and corrode. A lot of times what we see up in our market here are wood boiler systems that are open loop systems, meaning water's constantly getting dumped into that system, and they're using a cast iron Taco 009 pump. A cast iron pump is probably the worst thing in that application, but you can't, you can bring a horse to water, right? But you can't make them drink it. So just understand, if you're going to have a system that the water is going to get oxygen in it, you got to make sure that you're using non-ferrous materials in there, stainless steel heat exchangers, bronze or stainless steel pumps. Your air eliminator needs to be stainless. You can't use anything cast iron in that system. Okay, does that clarify it better?
For sure. Thanks, Patrick. Just when you mentioned the actual word Inflor, some people might have thought you were referring to the old polybutylene product that a company called Inflor was selling. And that would mean it did not have an oxygen barrier on it, right?
Sorry.
So I wanted to make sure, that's all. Just make sure everybody understood what you meant. Okay.
But it was a hell of an answer, Patrick.
I'm only 46, man.
Hey, this sounds like a good time to do our little trivia business. So I'm going to take the con from you real quick. Let's see. Change the presenter. Come back to me. Show my screen, and let's get this up here. All right. So it's trivia time for the Barney Miller Show. I hope you guys remember Barney Miller. Someone mentioned earlier that maybe one of the reasons Jacob was so grumpy is because we had a TV show. The trivia question was about a TV show from the 70s. Well, we tried to get a SpongeBob question. It just didn't work. But anyway, it's trivia time. And the trivia question is about Abe Vigoda. Okay. Abe Vigoda was also in The Godfather, the original Godfather, the first movie. The trivia question is, what role did Abe Vigoda play in The Godfather, or Godfather 1, if you will? You know the answer, type it in. You'll be put in our little spinning wheel, and we'll be selecting the winner for our prize pack that Dave has stashed away in his garage for you. And that'll happen at the end of the program. So what role did Abe Vigoda play in The Godfather? Write it down, type it into the question and chat section, and we'll put you in our wheel, and we'll find out who wins at the end. So with that, I'm dead. Let's go back to Patrick. Let's wait for this to finish. You'll like it. And I didn't even go out of the house this weekend. All right, Patrick, back to you, brother.
Okay. Screen. There we go. Okay, so as we look at systems, now we talked about treating the system, but what do you do if you get onto a system that's already dirty? You walked on the job and the thing looks like this. Or even some situations, I'm installing a new system or I'm doing a change out. What do I do to make sure that my water is going to look like this when I'm done and not like this? All right. So what can we do? Well, we can clean the system. All right. When we're looking at cleaners, you want to make sure that you're using a universal cleaner that's going to fit the system that you're doing it in. You want to make sure the cleaner is going to remove flux and residues and installation debris. Actually had a customer out in Washington that actually explained they had wood chips in one of their pumps from the construction. You want to make sure that the cleaner that you're using is non-acidic and non-hazardous. Now remember, cleaners are acidic, but you want to make sure that the acidity of that isn't going to damage the system. You don't want to wreck the metal of the system or the material that the system is using. And then last but not least, you want to make sure that your cleaner is compatible with all metals and materials in the system. Again, you want to make sure that it's not going to wreck anything in that system. Okay. I like this slide, and the initial purpose of this slide is a bit different than what I like to use it for. The initial slide was shown to show, you know, if you had a dirty car, you wouldn't wax a dirty car. You would clean it first and then you would wax it. And the idea was, remember, with the inhibitor that we have, neutralizes the pH, okay? Reduces hardness, so this also reduces hardness, so you're not going to plaque up a system. But last but not least, it coats the system and prevents corrosion from occurring. Okay, so one of the things they talk about is they say, you know, you would always clean a system first before you wax a dirty car. Well, I looked at it a little bit differently. I look at this car and I simply say this: I'm going to trade this bad boy in. I got my last nickel out of it. I'm trading it in. I'm going to drive this brand new Cadillac off the lot. This is the car I want. I've wanted it forever. I saved up. I got everything I needed out of this car. I'm trading it in. And I'm driving this one off the lot. And as I sit down in the car and I'm about to put the key in the ignition, the service manager comes out and says, hey, hold on a minute. Don't start the car yet because it's not ready. Well, what do you mean it's not ready? My check didn't clear or what? Well, no. See, we got to take all the fluid out of your old car. Okay. Brake fluid, antifreeze, oil, windshield washer fluid, power steering fluid, all the fluids. We got to take out the old one and put it in the new one because the new car doesn't come with fluid. Okay. So we got to take everything out of the old one, put it in the new one. And I always ask people when I'm doing the training or a class, I'd say, who would buy that car at that point? And more importantly, would Cadillac even warranty it? It's not a chance, right? But when we go and we change out that 50 and 60-year cast iron boiler, and we change that thing out, and we don't flush and clean it out, and we put in that brand new condensing high efficient boiler, That's exactly what we're doing. We're removing a boiler that had this running in it for years. And now we're going to put a new mod con in, and we're going to end up running this right through that new mod con. And I just showed you earlier in the presentation pictures of what happens to heat exchangers when we do that. Okay. Now, the worst part is this: there are people out there that do that, and then they expect that boiler, when it fails, to be warranted, which is exactly why manufacturers have now said credit upon evaluation. Okay. It's a big deal. It's very important. You have to clean the systems out before you treat them. All right. It's very important because this doesn't play nice in boilers today. All right. I was doing a presentation on this. I believe I was in St. Cloud, Minnesota. I had a guy that was just, he wasn't taking what I was putting down. And I called him out and I said, what's going on? I'm seeing you're really not accepting what I'm telling you here. So what's the problem? And he said, I've been doing this for 30 years. And I clean every system out that I do. I said, well, that's fantastic. What cleaner are you using? He said, I don't use a cleaner. Well, how do you flush the system? What are you doing? He said, I use raw water and I run it through that system. When I get that black water out and I've got clear water coming out of it, I know I clean the system out. I said, oh, all right. Well, that's how I used to do it before I got educated on cleaners and products. But let me ask you a question. You've been doing it 30 years. He said, yep. I said, well, when you get this black stuff on your hands, you're doing a job and you get that on your hands, and you go over to a sink with running water and soap and you scrub, you get your hands clean. He said, no, it stays on there for about a week. I said, okay, cool. But somehow, miraculously, running raw water through those pipes that have had this stuff in there for 50 years, somehow raw water that doesn't work with your hands, scrubbing, soap, everything, somehow raw water is cleaning that system out. And he looked at me and said, you got me. I said, I'm not trying to get you. I'm just trying to get you to understand. I'm trying to pitch a better way. We're trying to help you do a better job. And that's what this is all about. Water quality is a fantastic avenue to better ourselves and be more professional and ensure that condensing boilers last as long as condensing boilers are supposed to last. Okay, that's what this is all for. We look at ECM pumps. Taco put a protection on their pump because of water quality. Most boiler manufacturers out there now are putting inlet screens on their returns because of water quality. It's a really big deal. The fact of the matter is, anytime you're on a job, whether you're doing a change out or even a new system, I highly recommend flush and clean that system out first, then fill it with water, treat it with an inhibitor, and that boiler is going to last a long time. Okay. So does it help efficiency? Well, by flushing and cleaning a system out in Boston, Massachusetts, they had a Badaris GB 142 boiler, aluminum heat exchanger installed in 2007. They flushed that system out. It had 10 cast iron radiators and 2 flat panel radiators. And by flushing that system out, they saw an increase of efficiency by 15%. Now, I used to not talk about this slide until I really sat down and thought about it. If I change an 80% boiler out, and I put in a new 95% efficient condensing boiler in that job, what am I gaining? I'm gaining 15%, right? What does that cost? The reality is this: if the water looks like this, which there's many, many, many systems out there that it looks just like this. If that water is black and dirty and you clean that system up and you get water in there looking like this, you're going to gain about 15% efficiency. So just by cleaning a system alone, you're going to pick up 15%. Now, I want people to upgrade systems. I want people to be efficient. So the reality is simply this: when you find an old cast iron boiler that needs replacement and it's got this running in it, you can ensure that customer by cleaning that system out, because that's what you do every time you do a change out, and replacing that system with a 95% efficient boiler, you've just ensured that that homeowner is going to see a 30% increase on their efficiency. With gas prices on the rise and different things going on with our energy, this could be a much bigger deal than it was 2 years ago or even a year ago. So it's important to know what we're gaining by flushing and cleaning a system out. Okay. Looking at a US Water Hardness Map. This is a favorite map. I love this map because there's so many times where I'll talk about water quality and I'll talk about, different situations where water quality has created issues. And pretty much every time I'll have someone, if not many people in the room saying, oh, no, we don't have bad water quality where we're at. Well, I can assure you every market, every area that I've worked in the Midwest, and you can look at the map and it'll verify it, there's hard water, there's issues. My favorite is when I get around Lake Michigan, when I get around Chicago and I get around Milwaukee, and the people there tell me, oh no, you don't understand, our water's fantastic here, it's so good. Well, I'm looking at the map and I'm thinking, it looks pretty hard to me. What hard water and hardness in water will do is it'll start to plaque that system up, it'll start to scale, okay? And when you get a scaled system up, you can get kettling, okay? You can get heat emitters that are no longer emitting heat, and you can foul up a heat exchanger where you're no longer gaining the heat out of the burner like you're supposed to, and you can get overheating and short cycling, okay? One of the benefits of a good inhibitor is it can actually neutralize the pH and reduce the hardness. This particular one with Fernox, if the hardness is around 24 or 25 grains of hardness, it'll reduce it down to about 4. The reality is the limit of that inhibitor is 70 grain hardness. So if I get above 70 grain hardness, I then need to look at double dosing that system or adding more of the inhibitor to reduce the hardness, okay? So looking at the map, you can see the entire Midwest, a region we cover and represent, it's definitely prevalent to hard water. When you look out on the West Coast, you'll see you start to get into Southern California, you start to get up into the, I guess, the Northeast section of the nation, you'll see there is hard water issues in those locations. And even where it's saying slightly hard in the yellow, I can promise you there are pockets in that area that you're having issues. And more importantly, just because the water isn't hard doesn't mean it's good. You got to look at the pH, okay? If the pH is out of range on that, it's going to become corrosive as well. So there's more to it than just hard or soft water. Also, one thing I would tell you that I learned, if you have an aluminum heat exchanger, if you're using a boiler with an aluminum heat exchanger, the worst thing you can do to that aluminum heat exchanger is add softened water, okay? When we're adding softened water, we're adding sodium and potassium, okay? That can actually create foam in a system. If you've ever seen a system that's foamed up, there's a good chance that it was filled with softened water. The product we represent will accept softened water, but we'd rather see hard water out of it. Quite honestly, if you're looking in the market and you're doing anything with steam humidifiers, because of that foaming, they don't want to see softened water. Just some little tidbit to know on that as well with hard and soft water. Okay. One of the byproducts of hard water is lime scale. Calcium carbonate. It's deposits by heating hard water. It basically will start to plug a heat exchanger up, reducing the boiler heat transfer, causing higher fuel bills and blocked valves. One of the things that you'll oftentimes hear with lime scale that's very typical is kettling. And that's where the burner actually starts to create the water to boil because the heat can't get into water properly because of the lime scale buildup in the system. So you'll start to get like a kettling noise on the heat exchanger. That's a telltale sign that that heat exchanger needs to be flushed and cleaned out. Okay. Before I dive into the burner side, I wanted to talk, I had mentioned earlier, so how do I know when I need to flush and clean a heat exchanger out? How do I know a heat exchanger is plugged? One of the key indicators on a plugged up heat exchanger would be a high exhaust temperature. Anytime you install a boiler, you should always record your combustion readings that you're getting on the boiler to ensure that the next guy behind you knows that you set the gas pressure up properly, but also record your water temperatures and your flue gas temperatures, okay? If your flue gas temperature starts to exceed and starts to get higher while your water temperatures stay at a relatively lower rate, that's an indicator that I'm no longer absorbing the heat. I probably have a fouled up, plugged up heat exchanger, and I need to address it. So if you've got lime scale buildup, or you've got buildup from corrosion building up inside of that heat exchanger, like we showed earlier in the slide presentation, a high exhaust temperature is a I guess that's the key indicator for a plugged up heat exchanger. When we're looking at the burner side, you'll see here with this Giannone heat exchanger, you'll notice on the left-hand side, you'll see a heat exchanger that was not maintained. I will tell you with almost utmost certainty, if you see a heat exchanger that's looking like this, and you see the igniter is just very red or very looking in really rough shape, you're probably recirculating flue gas. Would be anytime you see this, this is almost a guaranteed indicator that you are recirculating flue gas and you're getting corrosion in there. Anytime your boiler recirculates flue gas and reburns that exhaust air as combustion air, it becomes very corrosive on your heat exchanger, and you're going to see a product of corrosion in the system. If you see a heat exchanger that looks like this, number one, check and make sure you're not recirculating flue gas. Number two, I would check my combustion rate. But more importantly, you got to clean it up. Well, with the line that we carry, we have a product called Fernox. That particular product has a burner side heat exchanger cleaner called D as in dog, S as in Sam, 40. Dry side 10. DS10 is the burner side cleaner. If I want to clean the water side, then I would use the DS40. So if you're cleaning the burner side, like the slide shown here in front of you, that's where you would use your dry side 10, your DS10 cleaner. If you're cleaning the internal of the heat exchanger, the water side of it, there's a product called DS40. That's a product you would use to clean that system out if you can isolate the heat exchanger. You would never want to put the DS40 out into the system because it's corrosive and it's going to open up things that are going to cause a lot of problems. All right. When we're looking at cleaning the entire system, that's where we look at a product called F3. It's a cleaner that we'd inject, just like the inhibitor. It's a cleaner we would inject into that system to clean the entire system out. Okay. That cleaner you would inject for 2 to 7 days, and then you would remove it. You let it run around in there. Don't go longer than 7 days. The way that cleaner works is it's a hydrophilic and a hydrophobic, and they bond together and form what are called micelles. Those micelles run around, float around into the system, and they grab dirt and grime from that system and clean that system out. Okay. After 7 days, those micelles can no longer hold the particles they cleaned into solution. It'll start to fall out. All right. Plus, it's an acidic cleaner, so you don't want it run around in your system more than 7 days, anyways. But generally speaking, you inject the cleaner into the system, and you let it run around in there for about 2 to 7 days. Get it all out, fill it with fresh water, and then you're going to treat it with your inhibitor. And that's how we treat a hydronic system that we're trying to clean. Okay. Looking at a fire tube heat exchanger, yes, the burner side on a fire tube needs to be serviced and maintained as well. Again, that DS10, the dry side 10 for the burner side, that'll be a good product to try and clean that heat exchanger out. Okay. We're going to dive into glycols a little bit. John, do we have any other questions right now?
Yeah, we have a couple. One was just a comment with a question. An old plumber's joke that once they cleaned the system, they had leaks everywhere. Is that a myth, or does that really happen?
So okay, it's a great question. It's a great point. So that's why I say if you're cleaning the system, use the F3 cleaner. Okay. This is aggressive enough to clean dirt and grime and contaminants out of the system, such as what's carried here, but it's not going to open up a can of worms. It's not going to create leaks. Heat exchangers, if you have a fouled up heat exchanger, that's where you want to use a DS40. It's a citric-based acidic cleaner, okay? So you can get it on your skin, you get it on your hands. It burns if it gets in a cut, but you're not going to lose anything because it's a citric-based acidic cleaner. But it's aggressive enough to get a lot of heat exchangers back online. I had 2 Pinnacle 299s that were down in Watertown, Minnesota with a company called Hollywood Heating. Jason Bauer is the owner of the company. Really good guy. He called me up and I got him this cleaner, flushed it through these systems. He used a whole package on it, but he got those boilers back online and they were plugged solid. So I know that DS40 is a phenomenal heat exchanger cleaner, but it's heat exchangers only, because I don't want somebody putting it out into the system and creating leaks, such as what the person that put the comment in there is talking about. So good point.
Okay, terrific. There's another one. What do you recommend when you're converting a 1-pipe steam system to a 2-pipe hot water system? Clean out those pipes.
Okay. Steam to a hot water system, and you can do that. Once you've converted it and you've gotten it, I would fill that system up with water. I would then put my cleaner in that system. I would let it run around in that system. I would then dump everything out. if that's not feasible because of the size of the system or the timing that you're in, we do also have a product called Fluid Filter and Protect. The one caveat to this, so this is actually basically 2 cans in one. It's the protector and the cleaner in one. The caveat to this is simply, you still need to flush the system out with fresh water and clean it up to the best of your ability. Then you would inject this into the system. The thing about this is, I have to have some type of filtration, magnetic, strainer, whatever, but I have to have some type of filtration that I can service and remove the particles and stuff that it's cleaning, okay? Because this is going to go and protect the system, but it's always going to clean. So I need to make sure that I have something that I can service and remove those particles and clean that. There's a reason your dishwasher and your clothes washer has a rinse cycle. You need to get rid of the dirt and grime that it's cleaning. So if I'm going to use this product, I have to make sure that I have some type of filtration to maintain and clean that system out periodically. Okay, good question.
All right, terrific. Here's one from Mark Davey. When you mention filling with fresh water, do you mean distilled water or tap water?
Okay, so if you want to use DI water, you most certainly can. I will tell you this. The benefit of the Fernox product is I can accept 70 grain hardness of water, 60 parts per million red iron rust, and still be within acceptance of that system, okay? That's on our glycol, that's on our F1. Basically, the F1 is the inhibitor in our glycol. We'll talk about that here in a second. But the reality is we have a very high acceptance of what we can use with water. There's other products out there that have limitations of how hard the water can be. There's some of them out there that require DI or distilled water, okay? We don't require that. So the answer to your question, depending on what you're using, you may actually have to use DI water or distilled water. Now, the thing I'm going to caution you on is this. I did a class up in Fargo, and I had some guys from a college up there that attended one of the trainings, and they said, well, we don't need to worry about your glycol. We don't need to use your glycol. We're using a glycol already. And I said, well, I get it, but you know, what are you using? They said, well, we're using brand X, but we don't have to worry about it because we're using DI water. I said, okay, well, that's great, but brand X, the inhibitor in brand X is a phosphate and a nitrate. And they said, yeah. I said, well, I just got done telling you phosphates and nitrates break down and die. And when they do, they become very using DI water. I said, I don't care if you're using holy water. It doesn't matter. When you have that system and you're using a glycol that's going to break down, you got to get back and check that system out. Well, they went and checked it, and they had an issue. So they flushed the system out with the cleaner, and they ended up putting my glycol in. Cute part is, a couple of years later, they sent it in to get tested, but they sent it into brand X. Brand X looked at it and had a raving review. Everything was fantastic, except they raised a big red flag. They said, hey, you got a major problem on that system, though. You don't have any inhibitor. So, of course, they called me up in a panic and said, hey, what did you sell me? And I said, calm down. They're looking for the phosphates and nitrates that caused your problem in the first place. We don't have that. Our inhibitor is this. It's the F1. That's not going to cause the problem. The F1 inhibitor should outlast the life of the boiler system. So then I took that sample, sent it into Fernox. They tested it, and everything was just fantastic and good. But that was that was one where people oftentimes will think, well, I use DI water, so I'm fine. Well, it depends on your inhibitor. If your inhibitor is going to break down, it really doesn't matter what water you're using, you're going to have a problem. The reality is, if you're using a product or a glycol that requires DI or softened water, you need to follow those instructions. The benefit of the product I'm about to show you is it's 70 grains hardness, 60 parts per million red iron rust. If I get above the 70 grains hardness, all I got to do is add another can of this to it, and it's acceptable in the system. And by the way, the inhibitors aren't going to break down, and they should outlast the life of the boiler. Okay, it's a phenomenal product, and I don't have to look at that. So that's a very good question. It leads into one of the benefits of the product we're going to talk about, and it leads into some of the questions and some of the things you need to know about glycols that, quite frankly, I didn't know until probably year 2 of working at this company. Just simply because if the question doesn't get brought up, you don't even know to think about it in some situations. So we've learned a lot with glycol. There's a lot of things that we're going to share with you in a short amount of time that I think are going to be very useful. So Any other questions, John?
Just one, but I think I'm going to save this one till you're almost done with this presentation. So I want you to get through that. Then we'll go and talk about cleaning the burner side. So knock it out on glycol,
right,
and we'll come back to it.
Okay, when you're looking at glycols, one of the key things that I like to ask is it aluminum safe? Because I've been a culprit. I've actually put the wrong glycol in the wrong heat exchanger, and with aluminum, it can be detrimental. So that's where I always say, you know what, if you're gonna have a glycol on hand, just have a glycol that you can't screw up. Have one that you can put in aluminum, cast iron, stainless steel, copper, it doesn't matter. So that's one of the benefits of the glycol we represent, the Alpha-11 from Fernox. It's acceptable in all of those metals. The other thing is you need to know what's the pH level of the glycol at solution. This is a big one, okay? The most commonly used glycol on the market today has a pH of a 9 to 9.5. On the pail, the instructions to that product tells you that if that pH gets down around 8.5, you have to add their inhibitor to it to raise that pH back up to that 9 and 9.5 where they want to see it. What's the problem with that? The problem is simply this. In the very beginning of this segment, I talked about what are the acceptable pH ranges in a boiler and what are the manufacturers looking for. And it is 6.5 to 8.5. I haven't found anybody that's ranged out of that range. 6.5 to 8.5. The glycol that a lot of people are using isn't even in range with the stinking boiler they're putting it in. That's a major problem. That's something that people need to be educated on, learn and know, okay? I was a culprit of that. I didn't know any better, and you don't know what you don't know until you know, right? Okay, so you need to know what is the pH level of the product and what is the pH acceptable level of your boiler system. The other question to ask is, how long is that inhibitor going to last? Okay, if it lasts 4 to 5 years, I need to make sure that I'm going back and checking it, because when an inhibitor breaks down, they become very corrosive and they can do some damage to a boiler very quickly. So you need to make sure that you're looking at the inhibitor in your glycol, and you need to make sure you know how long it lasts. One of the benefits of the one that we represent, it's going to outlast the life of the boiler, okay? What are the inhibitors made of, right? Are they phosphates, nitrates? What are they made of? And do they promote bacterial growth in low temperature systems, okay? If any of you have a dog and the dog has had a stainless steel water dish, that slime that's in there, that's a bacteria that in some cases is present in the water. That bacteria thrives at temperatures of 140 and lower. It grows and gets very aggressive, okay? Well, phosphates and nitrates can actually act as a food to that bacteria and actually promote the growth. It's very common when we see it in geothermal systems that don't get above 140 degrees. You'll see a substance in there. It's almost like a white snot, okay? That's a byproduct from that bacteria. So one of the things you want to look at when you're looking at glycols is it going to promote bacterial growth? It's a great question. It's something to look at. Obviously, the glycol that we represent doesn't do that, okay? The other thing is it a concentrate or is it a premixed glycol? There's a lot of stuff out there that'll actually represent itself as 100. Well, it's not really 100%, okay? It's a 70-30 mix, all right? The stuff that we're looking at, the stuff that we represent, you can get in 100%, you can get it in a 40%, a 30%. It's available in different mixtures. My recommendation is buy it in 100% because the benefit of the product is I can mix it with any water you find. I don't have to source water from another site. I don't have to fill it with softened water. I don't have to have a demineralizer when I'm filling the system up. My glycol is going to work with anything you throw at it. It's a fantastic product. Okay, so I like the concentrate. Yes, we have premix, but I like the concentrate because you're going to get more bang for your buck. But when you're comparing prices of different products, make sure you're comparing apples to apples as far as the mixture rate. Last but not least, I would tell you, follow the instructions. With glycols, the devil is in the detail. You got to know what you're putting in. You got to know the restrictions on it. You got to know the limitations on it. The benefit of the product that we represent and sell is simply this. If you're using our glycol, you're doing it right, okay? If you're using other people's glycol, what's the water you're mixing with it? How long does it last? Is it safe to put in the boiler system that you're looking at? There's a lot of questions that you need answers to if you're going to ensure that you're doing it right, okay? So those are things to know about with glycol. The glycol we represent has been a fantastic product. It has a very, very low limitations. It works in pretty much every environment that I've found. Okay. The downfall is with the products that we represent, we don't have a product for steam. So if you're doing a steam system, not a steam conversion to hot water, but an actual steam system, we don't have a product for you, unfortunately.
Unfortunately, this episode is way too hard to push on the.
Hey, Rickster, your microphone's on, Rick. I know he's texting right now.
Texting.
So why should you use a water test kit? Well, with water test kits, they provide professionalism. Okay, there's no guesswork. The cure, you're basically going to cure the cause, not the symptoms. So you're not guessing anymore. It's what professionals do. Okay, service tech can confirm inhibitor concentration, possible contaminants. You want to make sure that you have enough inhibitor in those systems, so you want to test for that. With water testing, some of the water testing out there, they can test for copper, iron, inhibitor, pH, hardness, and chloride. The one thing I would tell you with the water testing is simply this. I would want to know, do I have enough inhibitor in the system? What's my pH? And how hard is that water? Those three things to me are the very important things to know about when you're looking at boiler water quality. I think they're critical to know on a system, because we talked about pH. We need to know what's the pH of that fluid in the system, and we need to ensure that it's within range of the boiler system. How hard is it? Why is hardness important? Because hardness can actually start to scale up into a system and start to plug a system up. And then last but not least, the inhibitor test. You want to make sure that you've got enough inhibitor in the system to protect it. Okay. Just running through basic analysis when we're looking at copper. I always like to look at the action. If I got high copper in the system, I want to clean and flush that system out with cleaners and then put an inhibitor in it. If I've got high iron, typically if you see high iron or high copper, that's the problem, is nobody inhibited that water and you've got highly corrosive environment in that system. And that's pieces and parts of your system now floating around in the system. pH, if your pH is higher or lower than that 6.5 to 8.5 range, remember 7 is neutral. If I'm lower, I'm acidic. If I'm higher than that, I'm running alkalinity, neither of which is good for a boiler system. Okay. And then hardness, if the system has hard water in it, either I need to get rid of that hot water, I need to get rid of that hard water, or I need to add an inhibitor to that system to help offset that hardness so that it can't plaque up that system. Okay. Last but not least, you want to know, what is your inhibitor level? Is that system protected or is it not? Okay.
Very good.
I will
All
open
right.
it up for questions. Okay,
we got a few. Let's see. Well, first one, well, here's a couple quickies, and I want to get back to the cleaning the burner side. Patrick, you mentioned refilling the system with raw water. Should we not be using either a demineralized water with inhibitors or a glycol with an inhibitor? I think you kind of touched that, but just address Ken's question if we can.
It's a question. You're putting demineralized, mineralized water into it. That's all fine and well, but you still need an inhibitor. You still need something to protect that system from corrosion. Different metals are going to corrode at different rates. There's a lot of things that can happen in that system. So yes, I would absolutely fill that system up, and then I would put an inhibitor in that system. So when I say you're filling a system with fresh water, what I'm referring to is fill it with fresh water and then add an inhibitor to that system to ensure that you're not going to get any corrosion in it later on down the line.
Very good. And what kind of glycol do you recommend? Asked Jonathan Canner.
So the glycol that I prefer, because I'm familiar with it and I know it, is the Fernox Alpha 11. There's other glycols out there. The reason I like the glycol that we represent is because it's simple, it's very easy to use, and it has a very broad range of acceptance. And the thing that I learned about glycols is there's a lot of products out there, but you need to make sure and know what they accept and what they don't. Some of the products out there require DI water. Some of them have a limitation of how hard the water can be. You've got to fill them with soft water, which you got to pick your poison there. If you're filling with soft water, you're going to add sodium and potassium, but if the product you're using requires it, well, you kind of have to do it. You don't have much of a choice on that. Okay. So when you're using glycols, it's fine to use glycols, but you got to make sure that you know what you're using. And then last but not least, you need to make sure that the pH level of that product actually jives with the boiler you're going to put it in.
Yeah, that would say one of the big things I took from what you said. If that one company wants their pH to be around 8.5, 9, that was probably not meant for a ModCon boiler. It's probably meant for a cast iron boiler.
Agreed, 100%. Agreed,
Yeah.
100%. And John, we see it over and over again that it's put in there. Now, if that happens, you can put some inhibitors in it to bring that down. Okay. And I've got plenty of contractors out there that are doing that because they go, well, we've got all these systems out there. This is great to know. But we've got tons of system out there and we don't want to get rid of the glycol that's in there and whatever. Okay. You can inhibit that and bring that down within range. My recommendation is simply this: always go back and check those systems. Don't think you're off the hook, because I've had some contractors that added the inhibitor to it, okay, and neutralized it. But when the inhibitors in the glycol broke down, there wasn't enough of this in there to offset that change. So once they went back and checked it, they actually had to add more of this to offset that breakdown of the original inhibitors that broke down on the product.
Gotcha. Okay, a couple more questions here, then we'll go to our trivia. One is any value in a pool water testing kit that does metal testing as a test kit?
So generally, we just talked about this today in a meeting. So generally speaking, yeah, it's great to know everything in the water, but the reality is this: if you have a dirty system and it is contaminated with parts, components, and pieces, you know the product in there is bad. Okay, so to try and come up with a solution of why it's bad and how to treat it, generally the solution is always the same. You got to put the cleaner in it, run the cleaner around, dump everything out, refill it, and then inhibit it so that you don't get that problem again. So I kind of chuckle. We do a lot of testing, and it's okay, fine, we can test it, but the reality is simply this: the answer is going to be put the cleaner in, flush it out, and refill it with water, and then inhibit that water. Okay, I've oftentimes said this doesn't need to be tested. I can tell it's bad. Okay, it needs to be cleaned, and then it needs to be refilled and inhibited so that this doesn't happen again. You want it to stay like this.
Right. So you got one solution to solve many problems here.
Yes.
Yeah. One more here. If you use the right water, treatment, would you still recommend a magnetic separator?
Well, that's a good question. So the answer to that question is simply this: magnetic filtration is becoming a very important piece that people are finally starting to recognize. Yes, and it's an expense to add to a hydronic system, but to the whole system. The reality is it's a pump. So is a boiler. There's expense. A magnetic filtration device, okay, can take that expensive investment and make it last a long time. I highly recommend putting magnetic filtration in on brand new systems or existing systems that were cleaned out and used. It's just it's a good way to filter out any contamination. It's a good way to filter out any products of corrosion in a system that could possibly occur. Now, technically speaking, if you're using my product, flush and clean the system out and then refill it and inhibit it, should you need magnetic filtration? Probably not on a brand new system. But if it's a change out, are you sure you thoroughly cleaned it? Did you have a cleaner in long enough? Is there anything else that's maybe sitting in some of the dirt legs that are out in that system on cast iron radiators and things like that? You kind of need to consider the system and then evaluate the fact of, you know what, I don't know if we got this thing cleaned out as well as I want to. I want to get magnetic filtration on there to ensure that this investment's going to last a long time for that customer.
Hey,
Yeah,
Patrick.
it's not quite belt and suspenders, but it's pretty darn close.
Correct.
I mean, yeah, and it's not going to hurt you, right?
No, not at all.
Yeah.
Hey, Patrick.
Yes.
Clarify again. You said you could introduce water hardness up to 70, was it grains or parts per million?
70 grain hardness.
Okay, so that's way off the chart. I mean, that's almost, I'm just looking at a chart that I personally put together based on somebody else's information years ago.
Yep.
And anything 25 or higher as far as grains are concerned is considered, very hard. So you're even way above that. That would determine what, see, a grain is equal to 17.1 parts per million, right?
Yes.
Okay. All right.
Yeah, it can handle up to 60 parts per million red iron rust. So when you get in, like in Minnesota, you get up in the Duluth area, the iron range, that's actually where I found out that this product was worthy or worthwhile. I was talking to a geo guy,
Yeah.
and I was showing him the Fernox product, or this product. And he asked me about my glycol. I'm like, I don't know, it's a glycol. And he asked me, he said, well, how hard of water can you mix it with? Oh, what do you mean? I said, well, how hard of water can you mix it with? So I called my Fernox guy, Dan Slater, great guy.
Yep.
I said, hey, how hard of water can I mix with this? And he told me 70 grains. So I told the contractor 70 grains, and he about fell over.
I know.
I said, well, why is that such a big deal? He goes, I'm trucking in water to fill my geosystems. Because if I'm using your product, I don't have to do that anymore. And by the way, now we have the NSF rating as well. So we're food grade on our product as well. It can go anywhere. So that was a big deal. I didn't know it until he pointed it out. Once he pointed that out to me, I got educated with glycols really fast because I realized I had a huge advantage over my competitors. Well, then fast forward, now all of a sudden I'm out in the Dakotas. I had some colonies out there, colony project. They had 89 and 90 grain of hardness. So now I'm looking at it going, well, geez, can I even do this? The reality is, yes, I can. I just had to add more of this to that system to buffer that hardness down, Rick. They had jobs, they told me, up in Canada that were in excess of 110 grain hardness.
Yikes.
It's amazing.
Mercy.
So yeah, it's exciting to talk about when you understand how crazy that is with the acceptance that they have with water they can work with. It's pretty cool.
Cool. We got a few more questions here, but I want to get the trivia answer and then give it to Dave to pick our trivia winners. So great, again, outstanding work tonight, Patrick. Thank you so much. That's really informative stuff. And I hope you guys out there got a good dose out of this too. I mean, that's a lot of really good, solid information that you can use. And we're going to get to that question about cleaning the heat exchanger. That's the first thing we're going to do after we're done here with this trivia. So don't think I'm blowing you off. We're going to get to that question. So our trivia, yes.
That was an unintended pun.
What was an unintended pun?
Dosing.
Dosing.
Ah, baby.
Oh,
You're really good, and you didn't even know that one.
I may be Fish's age, but I still got it, right? So the trivia answer is Abe Vigoda played Sal Tessio, member the leader of the Tessio crime family. He was a capo regime under Don Corleone. So Salvatore Tessio is the correct answer, and Dave's gone through all of the answers that we gave, and he has two special things that he's going to do. So Dave, I think I'm going to turn this over to you now, correct?
I already took it.
You did? Well, okay, there it is.
There it is.
So here's the spin wheel with all of the right answers, including Patrick.
No, that's right. Yes. So Patrick, I even let you get a chance to win tonight because I think you should deserve one. So
That's right.
Since you were the one that were working and we got to sit back and watch for the evening. So yes, this will be for the grand prize. And if you were on with us last week, no, I did not send it out yet. I don't remember who won it. But they will be hopefully out by the end of this week. That is my goal. So anyways, we'll see if how many times John interrupted me tomorrow. So we'll see. So for the grand prize tonight. It's Micah.
Micah Moore. Congratulations, Micah. All right. And that grand prize is going to be, it will include a Takeo After Dark t-shirt. What else? Your Bluetooth speaker?
Bluetooth speaker, and I think I got a coffee mug and some other assorted accessories down there. So
Dave is the keeper of all of the goodies. So when he says he's got stuff, he's got stuff.
I got a whole pile of stuff, yes. And now, just because we wanted to, and a couple people have left already. Oh, Brian, you left already. But I put everybody's name in. So even if you didn't get to answer the question, everybody now has a chance to give on how many shirts, John?
Let's do 4 t-shirts.
4 t-shirts. All right, here we go. 4 t-shirts coming up.
These are exclusive, limited edition, very rare, very valuable Takeo
Rick
After
is
Dark
wearing his.
t-shirts, just like the one my man Rick Mayo is wearing. What's on the back of that, Rick? Look at that. All right.
It's a walking billboard.
You know it. Robert Wanandi has a Takeo After Dark t-shirt coming his way. Congrats, Robert.
Excellent, Darren. Daryl says he uses his coffee mug every day.
All right.
Felipe.
All right, Felipe Rodriguez. Congratulations. All right. And these are t-shirts, guys, you can feel very proud to wear. We had the opportunity to work with this company. It's a company out of Minneapolis called Elpis, and they make it's a, well, oh, Patrick. All right, we're gonna have to give away 5 t-shirts.
I probably should have sent one to him anyway, right?
Yeah, I think he gets one anyway, right? But Elpis is a company out of Minneapolis that it's a grant-funded organization that develops, they create jobs and teach job skills for at-risk and homeless youth. So part of the program is the guy who runs it has these guys draw up the business plans. He teaches them all of the work skills. He teaches them how to run a business, how to do accounting and all that stuff, and all of the soft skills involved and hard skills involved in running a business. So it teaches them life skills and work and business skills so they can, so they can get off the streets and and be employable. So it's a shirt you can feel very, very good about wearing. We're very, very proud to be able to wear it. And Brian, you got one too.
Yeah,
All right.
Except Brian just left, literally just left.
Yes, I saw it. He just left.
Yes.
So he'll never know. But no, well, when it
I'll
shows
send
up
it
on
to
his
him
door,
after
he'll
that.
know.
Yes, we got a whole bunch of people that witnessed it. So yes.
Very good. All right. Well, excellent. Okay. Now, Patrick, the question we've been hanging on is can you go into a little detail about cleaning the heat exchanger?
Okay, so when we're talking about, there's two sides to it. So if I'm cleaning the burner side, that's where you'd use like a DS10 or a dry side burner cleaner. Generally speaking, with a Giannone or a fire tube, you're going to spray that acidic cleaner in there, let it soak and break up the products of corrosion or the products from recirculating flue gas that build up in there. With the Giannone, you want to try and clean out in between each one of those tubes. As a former trainer that I worked with, instructor said you want to use your wife's credit card and wear that magnetic strip out in between each one. And the key to that is simply you want to make sure that the water can drain out of that Giannone heat exchanger, okay? Because the condensation will build up inside of there. Telltale sign if a Giannone is backing up with water because either the condensate trap is plugged up, the drain isn't right, or it hasn't been cleaned, is when you pull the white round cover off where your igniter hooks up, maybe it's the front of the boiler, you pull that white cover off behind it, or excuse me, the metal cover behind it is a white refractory. If you see a water line on that white refractory, you know damn well that thing's been filling up. You need to clean it so that it can drain that condensation out and get out of that boiler. Generally, a problem from that is going to be the igniters will be real white and chalky. And it's going to last a couple weeks to a month, and you're back there cleaning it again because that steam from in there will start to really cause that white oxidization on a sensor or an igniter. Okay, that's the burner side. The other side is the water side. The water side is where I'd have high exhaust temperatures, low flow. There's boilers right now that they're operating at 30% instead of 100% because they're only doing what they can because they can't emit the heat. They can't operate at 100% because it's plugged up. So that's where you'd use what I had said, the DS40. That's a more aggressive water side cleaner for a heat exchanger. And the way you do that is what I've done on boilers, because sometimes they're not piped up to do it. Perfect system is I've got a boiler, I've got a supply and return on the boiler. I'd have a shut off and a shut off, and I'd have boiler drains so that I can hook a pump, 2 hoses and a pail up. My solution is in the pail, and it just pumps it through the heat exchanger, okay? In one side and out the other. Those Pinnacle boilers that I was talking about, what we ended up doing, was hooking up to the bottom side on the boiler, okay, because it was valved off, but all I had on it was a boiler drain. What we did was we pulled the pressure relief and we screwed in a boiler drain on that 3/4 connection. That was how we flushed that cleaner through that system, okay? So whenever you're using a heat exchanger cleaner, you want to isolate that boiler or heat exchanger, whatever you're trying to clean, and ensure that you're not going to run it out into the rest of the system. You only want to run it through what you've isolated, because some of those heat exchangers cleaners are far too aggressive for the system, and you will open a can of worms and you will create leaks. So you need to be really careful with that.
Okay, I'm trying to send an answer here, but I can't send it at all. I'm gonna send it to everybody. There we go. Okay, good. Oh, I couldn't send it because he's left. Okay, there you go.
Why?
I was just kept hitting the send button and it wouldn't go. Let's see. This may be off topic, but need to ask at some point. This is Jonathan Cantor's question. What's the best way to inject antifreeze into a system? I know
Okay.
when I was in the field, we used to use a little giant utility pump. You know, we'd prime it and just have a bucket of antifreeze and pump it into the system. And when we were trying to purge, we just purged back into the bucket and kept going and going and going until we got it completely filled.
Well, I prefer to do it on a warm system. There's a catch to this. So what I like doing, filling a system up with the fill water, pushing all the air out down the drain, getting rid of all the air. I eliminate as much air as possible. I'll isolate individual loops on a radiant floor system, right? Say the wrong term here anymore. But I will isolate each loop and make sure I get all the air out of each loop. Then I'll open another one, get all the air out of it, open another one, get all the air out with the fill water. I will fill a system up, get rid of all the air. Then at that point is where I use a transfer pump in my glycol, and I will then add the glycol on the inlet side of the pump, and then down in the boiler, whatever I'm pushing in, I'll remove in raw water. So I'm putting glycol in, but I'm removing the water out. I'll then let the system circulator, once I get how many gallons I want in there, I'll let the system circulator mix it up. If it's a cold system, I had someone down in Rochester, Minnesota call me and complain that the glycol didn't work that he was using. Well, come to find out, it was minus 24 that day. Okay, minus 24. He's on a building that had no heat, and he tried to put water in and then mix the glycol in like I just described. That doesn't work. That glycol
system, right?
The system before he could even get it there. If you're filling a cold system like that, where there's a chance you're going to freeze, then you need to add your glycol as a mixed solution. So you need to pump it in as a mixed solution. The downfall of that is when you're trying to pump it in and remove air, you could be running some of your good product that you paid for down the drain. But if it's a cold system, you really don't have much of a choice. You have to do it that way. Now, some guys will use 2 pumps in a pail and they'll flush it through and run it through, and they'll try and remove air out of the pail that way. That's another way to do it when you see the bubbling there. But in most cases, those are the systems that someone calls and said it went down because it airlocked again because they didn't get rid of all the air.
Right.
In my opinion, the best way is fill the system with water, get all the air out on a warm system, then add your glycol and just let it mix in the system over a couple of days and you'll be fine.
Okay, yeah, that's good. I'd heard the opposite about not mixing glycol in the system, that it generally doesn't work. But I'm guessing that on a cold system it really would, and on a warm system perhaps it mixes better.
It'll mix up, yeah, and it'll mix up and you'll be fine. But again, the challenge that I ran into was if it's in fact a cold system, do not do that. You want to add it as solution to the system.
Very good, very good. All right. What other questions do you folks have out there? I think we got to pretty much everybody's. I think we got to the full backlog. Just now, I can open it up to you guys for whatever questions you might have. Just about TACO in general, hydronics in general. Any other questions that might be nagging at you? We've got 29 of you out there. So if you have any questions, please feel free to ask. Like I said, we'll stay on for as long as you like. Daryl Fern asks, what's the name of the cleaner to clean the combustion side on the Giannone? Was that the GS10 or DS10?
Yeah, that was the dry side DS10 cleaner. There's others out there. Again, that's the one that I represent and I know the best, and I know it works. The other thing I didn't even mention that works really well is we have a leak sealer as well that works very well. Got good feedback on that. And I actually found out the training we did last week, how does it work, right? And I didn't have the answer to how it
Right.
works. Well, the leak sealer, the way it works is it sees a pressure drop in the system, and then it also recognizes air on the leak. And at that point, that's where it would start to start to plaque up and try and plug up a leak. At the same time, I know it doesn't plug up air eliminators because I've been using it for 9 years, and I've seen it used on a low pressure geo system and it worked and didn't plug anything up. So the cleaner I have, I know works. I've also gotten feedback that there are some others out there, leak sealer that I have, I know works. There's some others out there that I had heard they had in fact plugged up strainers and things like that. So you need to be careful. If I had gotten any bad feedback on this product in the last 9 years I've been here, I certainly wouldn't talk about it. Got really good feedback. It works. My advice is you can find the leak, fix it. Don't try and use a leak sealer. If you can't find the leak and you've got that nuisance thing out there, give it a try. I think you'd be pleasantly surprised at how well it works.
Very good. Very good. One just came in from Jonathan. Let's see. On a Buderus GB42 to clean the heat exchanger that you access from the top, do you use the DS10? I'm not familiar with the heat exchanger on the GB42. Rick, do you know much about that one?
I don't know a lot. The GB series was aluminum, extruded aluminum heat exchanger, and we'll have to clarify if he's talking about the fire side or the water side.
He's talking about the fire side. I think that's the one where you clip. I think that's the one where you actually clip off the top. It's almost like an engine on a car. The top comes off with clips. If that's the model I'm thinking of, I'm not an expert on that brand. I think that's it. It is aluminum. Anytime you're cleaning aluminum, obviously you need to use some type of an acidic to clean it up, but you've got to use, in my opinion, get it flushed out, get it out of there as quickly as possible once you're done cleaning. And you may even want to use a neutralizer on that once you've cleaned it and get it out. But that's the challenge with aluminum, right? I mean, it's not the end of the world, but you need to know what you're working with and you need to know to work with it properly. So if you're doing the aluminum, personally, I would check with the manufacturer and go with what they recommend, honestly. There's a lot of boiler manufacturers that recommend what we have as a product. But if I'm working with aluminum, I want to make sure I'm using what they recommend. I know our product will work, but I would check with the manufacturer just to ensure you're doing what they want.
No, you don't want to leave something acidic on that aluminum because,
Oh,
yeah, that's not a good, not a really good mixture.
Or any metal.
Exactly, any metal, but there's some that are more
Noble.
susceptible. Yeah, exactly. The one thing I'd say with those products as well is recirculation of flue gas will knock them down right away. There's a single boiler out there that wants recirculation of flue gas, by the way. What I've noticed with some of the aluminum heat exchangers is they'll get hit harder than some of the others. And it's not a pick on the boiler. It's not a pick on the metal. It's a pick on, guys, we need to quit recirculating flue gas.
That's right.
Yeah.
And Chris S., and if he's not related to you, this is maybe one of the world's greatest coincidences.
I think he's making a point there.
Sure. He might be.
He might. Who could have seen this coming? But what type of brush should be used to clean the burner side?
Oh, so okay. So Chris is a coworker of mine. Good point. I appreciate him bringing it up. You never want to use a metal wire brush when cleaning a heat exchanger because you're damaging it. You need to use a nylon brush, something that's not going to damage that metal. You want to use an acidic cleaner, but an acidic cleaner that's not going to damage or strip the metal. And you want to use a nylon brush, something that's not going to scratch, scrape, or damage that metal. Period. Very good point. It's something I didn't point out, but it's important to know. And again, a hotel key or your wife's credit card, whatever you find more handy on cleaning out on the Giannone style. But you want to make sure you're using something that doesn't wreck the metal.
Very good. And a couple more come in. Daryl Fern is having a tough time finding the DS10 on the Fernox website. It comes up in a Google search, but not on the Fernox website. He was just wondering if you know anything about that.
If he wants to shoot me an email, I can get him information on it. If I know what region he's in, I can steer him to the right representative to get him taken care of as well. Daryl, if you've got a pen handy, or if we can share it somehow, but my email is P as in Paul, E as in Edward, S as in Sam, S as in Sam, at Mondale, that's MONDALE.biz, B-I-Z.
Got it. All right. Let's see. What causes recirculation of flue gas?
Aha, that's a whole nother question.
What causes that?
Question. So different models, different boilers out there actually have different causes of this. Some boiler manufacturers, actually, if you didn't install the vent in the collar far enough past the gasket, you can get recirculation of flue gas. So that manufacturer actually put a vent and safety switch in there to ensure that that pipe was pushed all the way down.
Yeah.
One thing that can cause recirc. The other thing is with your exhaust pipe and your intake pipe, having them too close together. Or I've seen situations where the exhaust pipe was lower than the intake. Well, what does warm air do? It rises. Anything that's going to allow that exhaust air to come back in the exhaust, we don't want that recirculation. That's a killer for a boiler heat exchanger, and I mean an absolute killer. The other one I'm not a fan of. Every boiler manufacturer out there allows it. They allow you to use concentric vents. Single penetration, you got the exhaust going out, and then you've got the thimble hood where it draws in from behind. The problem is all of these condensing boilers modulate down. When they modulate down, the velocity of that exhaust going out is not very high, and they will get some recirculation back. There's a single manufacturer I know that likes concentrics or wants them used on their product, but they don't prevent it, or they don't say you can't do it. They all allow it. I kind of wish they didn't, because I know concentric vents can be a big culprit of recirculation of flue gas. And it's not just boilers, it's furnaces, it's all those modulating appliances out there today.
That's right.
But it's another thing that can cause recirc of flue gas.
Yeah, I think there was a good presentation by a friend of ours that does some venting training classes on Thursday nights every other week. Patrick, I'm sure you attended one or two of those, I'm sure.
Thirsty Thursdays?
Thirsty Thursdays, yes. He recently did a venting class, so take a look at some of the older ones there, and you'll see what's going to cause recirculation. Yeah.
Well, one of the key things that we used to teach is just, take the chimney out the
I
roof
will say, as a
and take the intake wherever it makes sense. And that way it keeps them far apart, and you're not going to get any, recirculation. And what we used to notice is the venturi would be the first thing that would show up as any flue gas recirculation, because it would begin to eat that venturi a little. Again, that was one particular type, but that was the telltale sign. You reach in that venturi, put your finger in there. If it came out all black and sooty, you knew you had flue gas recirculation. And it was just something we said, hey, you guys just keep those two as far apart as possible, and you'll be fine.
And some of that, Rick, so when you saw the venter motor in the wheel, you saw that falling apart.
Yes.
From the acidity of that air coming back. Saw a lot of that. The other thing I would caution on is, you saw the soot in some of those venturis. Some of those units were actually, the cause of that was a plugged up heat exchanger and short cycling of the boiler. And by the short cycling, then the igniter got weak, and it wasn't lighting on the first try, it was lighting on the third try. And you were getting a backfire on combustion on it. And I literally witnessed out of the Ventura, and it was sooted from that. And so it was kind of from the factory, they had pinpointed, oh, it's recirculation of flue gas. But what we ended up finding was, no, the heat exchanger was plugged up and filthy, and the damn thing was sitting there short cycling and then getting rough light off, which was taking them out. It was one of the things we kind of ran across. The other thing I'll tell you as a rep, what we've seen with different boiler manufacturers that we actually represent, know what you can common vent. Follow the guidelines on common venting. Understand the do's and don'ts of common venting. We've had situations where people have common vented a series of boilers, okay, and they're all cascaded together, and then they common vented another appliance in that same line. Well, you can't do that, okay? We've seen a lot of situations that can cause recirculation of flue gas and venting issues, which that's just a killer on a boiler.
And one, Timothy Swiden says, many burner manufacturers use flue gas recirculation to lower nitrogen oxides. Now, I'm not a combustion guy, but I'm going to presume that's correct. And I guess that's maybe a good thing for the burner, but not a good thing for the heat exchanger.
I'm curious who they are.
Yeah.
That's probably big power burners. Let me clarify that, right? The big
Yeah, you're
power
probably right.
burners, commercial applications, but not the, you know, up to 399, so to speak.
Mm-hmm.
Well, quite frankly, every boiler, I mean, even the 2.4 million BTU units that we sell, they don't want that. That's an absolute no-go. Now, if you're talking about some of the burners out there that can burn oil or natural gas, and they switch over, like was on the college back when I was in tech school that we looked at, maybe those types of burners accept that. But the majority of the stuff that's being represented and sold today, as far as high efficiency and condensing products out there, I don't know of a manufacturer that's going to want that in their system. But again, some of the other multi-fuel boiler systems with the injection burners and gun burners out there, they might accept that. I don't know enough about those to speak intelligently on them.
He's clarifying that. He said, yes, it was on a power burner. So.
Yeah, okay.
Very good. We got a couple of good nights here from Ken and from Eric Hoffman. Very good. Another good session, says Jonathan Kantner. So, hey, this is terrific. Once again, thank you, Patrick. This was really a lot of fun and thoroughly enjoyed it, as always. And we hope to have you back again, back again on Takeo After Dark real soon. This was really awesome. And thank you all out there for being with us. This was a yet another BAFO event, and we're so psyched to be back on the saddle here. And we'll see you next Tuesday night, both tomorrow night and next Tuesday night. Our topic will be 3-speed circulators. Do they still have a place? They're kind of the forgotten stepchild here, but do they still have a place? I would say the sales numbers tell us yes, they do. Yes, they do. We still sell a ton of those things, despite the growth of the ECM offerings. Why, when, and where would you use them? What's the difference? What are you giving up? What are you gaining? We'll take a look at that in our next presentation. So we're really excited about that. Everybody, have yourself a great evening, and we will talk to you real soon. Patrick, thank you, man. Awesome.
Hey, thank you guys. I really appreciate the opportunity. Have a great evening.
All right. Take care, everybody. We'll see you soon.
See you later.